Hey everyone, Mr. Howey here. This week for grade 9 science, we're going to be doing more circuits, obviously. Today I'm going to walk you through what you should have discovered from week 1 and 2. So we're going to go over these weeks just so that it makes sense of what we do today, because it all kind of builds on each other. So just really quick to go over what we learned for series circuits. If you have a battery, so it says here 9 volts, so that means this is 9 volts. Okay, it also says here, assume that we used 9 ohm light bulbs for resistance. So we put 9 ohms here. So a circuit is pretty straightforward if you only have one bulb. So the voltage here is obviously going to match the voltage of the bulb. The resistance of the bulb is obviously going to match the total resistance of your circuit. And so the only thing missing is current. So if you did a good job discovering current on week 2, or how all these things were related, you probably would have discovered a way to calculate current given the other two. So the big thing you would have learned last week is this formula. Okay, the reason why this formula is so useful is that it helps you find voltage, yes, but it can also be rearranged to find you current, or it could be rearranged to find you resistance. So we're going to be using this idea a lot today. So I'll show you how to use it to find this missing piece here. So if I want to find the current going through light bulb number 1, I'm going to be using these numbers. Okay, so I'm going to say voltage divided by resistance. Obviously 9 divided by 9 is 1 amp. And same thing here, 9 divided by 9 is 1 amp. Okay, let's take a look at a few other circuits to get the idea. So again, we see that my total voltage is 9. We've been told to assume that every light bulb has 9 ohms. So what you learned in week 1 when you did this activity was that basically this 9 volts has to be kind of split up between these other two bulbs. So if you have two bulbs, this voltage is going to have to be split up. Okay, it's split up evenly because these bulbs are identical. Okay. So to find current, again, we do the same thing. We say I equals voltage divided by resistance. So we can see here 4.5 divided by 9 is 0.5. Okay, again, 4.5 divided by 9 is 0.5. So you can always use this formula to find the missing piece. The other thing we realized in week 1 was that current is always the same in series, so there's only one path. So because there's only one path, if you discovered 0.5 amps here, 0.5 amps here, obviously it's 0.5 everywhere. Okay, so we say 0.5 amps. Now that we know these two pieces here, we can find the last piece. And so we can realize that resistance is voltage over current. So voltage is 9, current is 0.5, so the resistance, the total resistance, has to be 18. So basically what we're learning this week is that if you're given some kind of circuit, I'm showing you how to use the formula V equals IR and how to use the stuff we learned from week 1 in order to find all these missing pieces. Okay, so let's do one more, and then I'll sort of simplify all the rules, and we'll take a look at some more examples. So here we have a circuit. Again, we're using a 9-volt battery. So we say this is 9 volts. We know that the resistance of every single bulb is 9 ohms, 9 ohms, 9 ohms. And we just saw from earlier that in series, resistance 1 plus resistance 2 will equal the total. So 9 plus 9 is 18. So here we have 9, 9, 9. So the total is 27 ohms. Okay, so with this in mind, we can find out every other missing piece. So if we look at the current, and we want to find the current here, well, I can just say that the current should equal voltage divided by resistance. So the voltage is 9, the resistance is 27, so it's basically 1/3, so I can say 0.33. So I know the current is the same everywhere, because this is a series circuit. So in series, the current is always the same. That's what makes it really simple for series, is that whatever the current is in one spot is the same everywhere. Okay? So now we can calculate the voltage here. We can say that voltage equals current times resistance. So if I want to know the voltage here, just multiply these together. So 0.33 times 9. Okay, great. 3 volts. Again, 3 volts. Do it again, 3 volts. Which kind of makes sense because as you were discovering in week 1, 3 volts here, 3 volts here, 3 volts here will equal the total of 9 coming out of the battery. So because all of these light bulbs are identical in their resistance, you would expect that their voltages to be identical as well so that they match the total coming out of the battery. Okay, so let's summarize all of the rules for series circuits. Okay, so if we look here, we can calculate the total currents coming out of the circuit using this formula. Now, it's kind of funny to call this a formula because we're basically just saying it's equal all of the time. So anytime you know the current of light bulb 1, you also know the current of 2 and 3, and you know the total current. It's all the same. So in series, it's all identical. If you want to know the voltage, so VT, the total voltage, you're going to say that equals V1 plus V2 plus V3, and so on, right? So if you had more light bulbs, basically the voltage has to be split up between all of those pieces. Okay, the new piece I just showed you today says that if you want to know the total resistance for your circuit, you can see here 9 plus 9 plus 9 equals 27. So this is pretty straightforward as well. All of them should add up to the total. Okay, so the formula for this week that you're going to find really useful is V equals IR. And I'm going to show you how that's super useful for the worksheets we're going to do this week. Okay, then we have parallel circuits. So again, we're noticing that we have 9 volts coming out of our battery. So that's VT here, 9 volts. And then if we look at our resistance, again, we're assuming that everything is 9 ohms, 9 ohms. Okay, so in parallel circuits, we discovered during week 2 that if the voltage is 9 volts coming out of the battery, that should match here and here. Okay, so we know that the voltage in parallel is always the same. So this path is getting 9 volts, and this path is getting 9 volts. Okay. For the current, we can use the formula I just introduced you to today, V equals IR. Again, it can be rearranged to find all the other missing pieces. So the missing piece we need in this case is this formula here. So we're going to say, okay, I wonder what the current would be because right now we're not using the internet. We're not using that app to figure it out. So we say that the current is voltage divided by resistance. So I say here this is 1 amp. Same here, 1 amp. Okay. And then what's interesting about parallel circuits, you would have seen this again in your other week, is that if 1 amp is going through this side and 1 amp is going through this side, this means what's leaving your battery is 2 amps. Okay, if you need a refresher, just go back to the FET app and you can try it again and check to see that in parallel, that the current is always the others added up to equal the total. And then we're trying to figure out, well, what would the resistance be? Because this is kind of weird. This is new. So if the voltage is 9 and the current is 2, and I want to know this last missing piece, I can say voltage divided by current. So 9 divided by 2 equals 4.5. I know it's a lot right now, but once we kind of review the whole thing, take a look at some examples, it'll make more sense. Okay, if you have a parallel circuit with 3 light bulbs, okay, so again, we still have a 9-volt battery. We're still assuming that all of the light bulbs are identical. 9 ohms, 9 ohms, 9 ohms, okay? And we know that in parallel, the voltage is always the same. Okay, that was something we discovered in the other weeks, which is why I'm reviewing it now. So the voltage is the same everywhere. And then we want to know the current. So same idea as before, we want to know the current. So this formula is going to be really useful. So if I want to know the current here, that would be volts divided by resistance. So I do 9 divided by 9, I get 1 amp. 9 divided by 9, 1 amp. 9 divided by 9, 1 amp. Okay, and as we learned before, the current, if you have 1 amp going through this path, 1 amp this path, 1 amp this path, okay, 1 plus 1 plus 1, you get 3 amps. And whenever you want to know the last missing piece in this row, use this formula. Okay, so you're going to use V equals IR, or you're going to use I equals V divided by R, or R equals V over I. So basically, whenever you need this last piece and you have the other two, you just look to your formula sheet to do that. So resistance here turns out is voltage divided by current. So here, 9 divided by 3, so we get 3 ohms, which is kind of unexpected, right? So you're thinking that this has a resistance of 9, this has resistance 9, this has resistance 9. Why is the total resistance 3? Well, basically what we're discovering is that in parallel, whenever you add more paths, that actually lowers the total resistance, because adding a new path just happens to reduce the overall resistance of the circuit. So this path is 9 volts, 9 volts, 9 volts. So when you think about the total resistance for the circuit, it's actually lower than 9 because you've added more paths. So because there are so many more paths, you have way less resistance. Okay, so let's summarize the rules for parallel circuit. So if you're looking here for what we call Kirchhoffs laws, so same thing we did with series circuit, we're going to write down what we discovered. So we've learned that the current, so the total current, is always all of the other ones added up. So I1 plus I2 plus I3 and so on. Okay, we know from last week that if we think about the total voltage, it's going to be V1 equals V2 equals V3. So the voltage is the same for every path. Every single path is going to get the same voltage. If we look lower down to resistance, okay, resistance is a totally new formula. We're probably not really going to use it, but just for the sake of how this works, it turns out it looks like this. Again, if we were teaching you this in person, we'd probably focus on this more. It's kind of hard to show you from where we are now, but this is how the total resistance is related to the others. This is a formula that basically just shows us that the total resistance is going to be lower than the resistance of every single path. But again, the main formula you're going to find really, really useful this week is V equals IR, because you can change it into other formulas like we saw before of I equals V over R, or you can change it to the formula that says R equals V over I. Okay, so now I can show you what we're actually going to do with these different formulas that we've learned in the past few weeks. So first thing I'm going to use, the most useful one, is going to be V equals IR. So that's this one here. So the reason why it's so useful is that anytime you have two pieces of information, like here, you can always find the third piece. So what I mean by that is here we've been given the total voltage of 9, we've been given the total current is 0.5, so we can find out the total resistance by using this formula. So it says here voltage divided by current, so we go 9 divided by 0.5, so we get, whoops, not 4.0, get 18. Okay, so 18 is your resistance. Okay, then we can use Kirchhoffs laws anytime we need to find out missing pieces this way. Okay, so we can use Kirchhoffs laws to do that. As a reminder, Kirchhoffs laws were back here. Okay, so Kirchhoffs laws are any of these circled in red. So if we need to find the current is the same everywhere in series. If we need to find the voltage total has to equal all the other voltages added together, and then the resistance total has to equal all the other resistances added together. So we go here and we realize, okay, we've been given this is 9, this is 3. I know that this plus this must equal 9, so the missing value here is 6. okay, because 6 plus 3 is 9. Okay, again, I want to figure out the current. So anytime I want to figure out for missing pieces in the column, I go to Kirchhoffs Laws and I see, are any of these useful? So notice here, the one for current says that it's the same everywhere. So super easy, I go here and I say 0.5, 0.5. Simple. Okay, now I want to find out the resistance. So I go in here and I check for my resistance and I say that, well, this is 3 volts, this is 0.5 amps, so I know it's voltage divided by current. So 3 divided by 0.5 is 6 ohms. 6 volts divided by 0.5 amps, so 6 divided by 0.5 is 12. And now I have all the pieces. Okay, you can also check your work to make sure that 6 plus 12 equals 18, so everything seems good. Okay, so let's try another one. So here again, I have another circuit. So this one has 1 battery, 1 light bulb, 2 light bulbs, 3 light bulbs, okay? Or 3 devices, it doesn't matter what they are. So we notice that we've been given a totally different set of information. We've been told the voltage that each light bulb is getting. So the reason these are different is because these are not identical devices. Okay, so if they were identical devices, we would expect the same voltage, but the question is telling us that they're different. So that's fine, because anytime we want to figure out any missing piece in a column, we go to Kirchhoffs Laws for voltage, and it says here all of them have to add up. So that's fine. So we see here 4 plus 6 plus 8, so this is 18 volts. Okay, for current, we want to figure out missing pieces in the column. So you go again, Kirchhoffs Laws, you look at them, it says equal all the time. So that's great. So we say 2 amps, 2 amps, 2 amps. Okay, and then we get the resistance. We want to find that out. So anytime you have 2 pieces, you can always find the last piece. Okay, so we know that resistance is voltage divided by current. So resistance is this divided by this, so 18 divided by 2, so 9 ohms. We can figure out this, 4 volts divided by 2, so 4 divided by 2 is 2, 6 divided by 2 is 3, 8 divided by 2 is 4. And again, we can check our work because we know that this plus this plus this should equal 9. So 4 plus 3 plus 2 equals 9, so we're good. Okay, and we have one more we can try. Okay, so this last one, again, we've been given different piece of information. I've been shown that these light bulbs are different because these two have the same resistance, but the last device is different here. So we can use Kirchhoffs Law. Anytime we have a lot of information in the column, we can figure out the last missing piece. So know that this plus this plus this equals the last one. So this would be 20 ohms. And now I'm happy because if you look at this row, I have 2 pieces of information and I need the last one. So I know that current always equals voltage divided by resistance. So I can say voltage divided by resistance is 0.5. And in series, it's great to know that the current is the same everywhere. So everything here is 0.5. The last bit we need to do is voltage. So again, for voltage, because the light bulbs are not identical, you can't just divide by 3. So we're going to use this rule of V equals I times R. So that's why I said this is a really powerful formula. So 0.5 times 5, so this is 2.5 volts. 0.5 times 5, so 2.5 volts. And then the last one, 0.5 times 10, so 5 volts. And we're happy because 5 plus 2.5 plus 2.5 equals 10, so we're good. And that's it. That's how you do series. Okay, so now we're going to look at parallel circuits. So again, the same idea. We're going to use these formulas. The V equals IR is very, very useful. Okay, and similar to before, we're going to use Kirchhoffs laws again anytime we want to find the last piece in a column. Okay, so just a reminder of Kirchhoffs laws for parallel. They're a little bit different. We see that the current, the total current always equals the other currents added together. But the voltage formula becomes really easy. So voltage total equals V1 equals V2 equals V3. So it's the same everywhere. Resistance is tricky. We'll probably avoid this one. If you stick around to the end of the video, I'll show you if you really, really want to know. But these should be powerful enough to figure out everything we need to do. Okay, so Kirchhoffs laws. So we see here we've been given voltage. So because we've been given a voltage somewhere, we know the voltage everywhere. Okay, so because this is 9 volts, we know that every single path is getting 9 volts. Okay, so that really helps us get started, because now that I know this is 9 volts, I know this is 9 ohms. So we can use this rule, I equals V divided by R. So V is 9, R is 9, so this is 1 amp. This is 9, this is 9, this is 1 amp. Okay, then comes using Kirchhoffs law to find out the total. Okay, so you can see here that for parallel, okay, the total current equals the others added together. So the total current here would be 2 amps. And now that I know that this is 2 amps and this is 9 volts, we can find out the resistance, because anytime you have 2 pieces, you can always find out the last one. Okay, so 9 volts, 2 amps. So we look at this formula, voltage divided by current. So 9 divided by 2, so this is 4.5. Okay, so again, we know that it's lower because in a parallel circuit, it's kind of interesting that adding more paths lowers the resistance of the circuit. So yes, I know this is 9 ohms, this is 9 ohms, but the total resistance for the circuit is actually lower because of the number of paths. So let's look at 2 more examples and then we're good. So this one, we've been given a bunch of information about the current. So because we've been given a lot of information about the column of current, we can use Kirchhoffs laws to figure out this one here. So we're going to say 1 amp plus 1 amp plus 2 amps equals 4 amps. And that helps me discover the total resistance over here. So once you know any 2 pieces, you can always find out the last one. So I'll remind you the formula we have at the top. Okay, so resistance equals voltage divided by current. So 12 divided by 4. So this is 3 ohms. Okay. We've been told the voltage. So in parallel, if you've been told the voltage at one spot, that means you've been told the voltage everywhere. Okay, so this is 12 volts all the way down, which is really helpful because that helps us calculate the resistance at any point. So 12 divided by 1 is 12. 12 divided by 1 is 12. 12 divided by 2 is 6. Oh, I'm writing volts for some reason. It's ohms, ohms, ohms. So again, I know it's a little bit strange, but in parallel, the resistances are going to be higher for each individual bulb compared to the total. Okay, so in parallel, you're going to notice the total resistance is not really going to match these. Okay, it's not as simple as adding them together. And again, I'll show you at the end of the video why that is. But it's still true that the resistance here equals 12 divided by 4. So we're pretty happy with that. The last example. So here, this is just a slightly different way to draw a parallel circuit. So again, you can see that it's splitting into 3 paths here. Okay, but it's just one big circuit. So we've been given the voltage of the battery. So we've been given the voltage at one spot, which means we've been given the voltage everywhere. So this is 12 volts, 12 volts, 12 volts. We've also been given the resistances of some different bulbs. So what's great is that here we have two numbers and we're missing this last one here. So we can use this formula to figure it out. So we can say that current is voltage divided by resistance. So this would be 2. This again, voltage divided by resistance. So 12 divided by 2 is 6. 12 divided by 6 is 2. And we're pretty happy with this because 2 amps plus 6 amps plus 2 amps equals our 10. And then we can figure out the total resistance as well here. And we can see that 12 volts divided by 10 amps would be 1.2 ohms. Okay, so that's it for today. If you want to see a different way to calculate this, stick around to the end. But for now, you know everything you need to do the worksheets. So the worksheets will look very similar to this. Okay, you'll have 4 series circuits, you'll have 4 parallel circuits, you'll figure out all the missing pieces, and just think of it like a puzzle, right? So use these formulas at the top, right? So use V equals IR, use I equals V over R equals V over I, and the Kirchhoffs Law. So it really helps if you have these kind of sitting on the computer. So you have your parallel one, you have your series one, right? So you'll need these formulas in red, plus the formulas here. So you would have access to a formula sheet in class anyways, so it's not a big deal, but try to use those and figure out the puzzles for the week. Okay, that's it everyone. Stick around if you want to see how to use this very strange formula, if you're very curious. Okay, bye everyone, see you next week, and please send in your work to the classroom. Okay, so this last part of the video is for those who are very, very curious how to use this formula here. So this was the last of the Kirchhoffs laws for parallel. Okay, so it says that 1 over RT equals all the other ones added together, but it's kind of strange because it's 1 over R1, 1 over R2, 1 over R3. So if you were curious how you would use this formula, so you would say 1 over RT equals 1 over 6 plus 1 over 2 plus 1 over 6, okay, because 6 goes here, 2 goes here, 6 goes here. So if you remember how to add fractions, you have to kind of remember your math class. They have to have the same denominator, so you change them all to have the same denominator. So now you can add them all together. So we had to change 1/2 to be 3 over 6. So now everything is over 6. So we can keep going, and we can say 1 plus 3 plus 1, so this is 5 over 6, okay? And then you can do some cross multiplying if you wish. So this is what I mean by it takes a lot of steps. So we get 6, 5 RT. Basically, you end up with 6 over 5 equals RT. This is your answer. Okay, so you may remember in the video, we said that our answer was 1.2. Well, what's 6 divided by 5? This is 1.2. Okay, so we did all that work to figure out our answer of 1.2, right? But in the video, I just said, make your life easy. Use this formula, R equals V over I. So we saw in the video, 12 divided by 10 is 1.2. So either way you do it is fine. I'm just saying probably the easiest thing to do is 12 divided by 10 to get 1.2, rather than doing all of this work to realize that it's 1.2. Okay, that's it. And we know we're good. Oh, did it just crash for no reason? Oh, I'm doing the wrong worksheet. I'm doing the wrong worksheet.